Hey everyone, so today we're going to solve LeetCode 491 non-decreasing subsequences, and it's a medial level problem. It's a pretty famous problem, as you can see, and in my opinion I think it's a very well balanced medium level because it involves some of the topics of DSA that are not considered as easy, but due to the constraints are very low, constraints are not that much of a problem, so I think it is a well balanced medium level problem. So let's see. We are given an integer array nums, return all the different possible non-decreasing subsequences of the given array with at least two elements. You may return the answer in any order. So first of all, we need to understand what is a subsequence. Subsequence is, for example, we have 0, 1, 2, 3, 4, right? A subsequence is from 0, we have 2 and 3. For example, we are having these elements, that is 0, 2 and 4. This is a subsequence. 0, 1, this is a subsequence, and 0 is also a subsequence. The thing is, they should follow the same relative order. For example, 0 is appearing before 2 in this subsequence, and it is appearing before 2, and 0 is also appearing before 2 in the original nums array that is given to us. So this is a subsequence. I think this must have been clear because this is more like a simple walkthrough. But if you want to get more information regarding subsequences, then you can obviously Google it up or check it on the Geeks for Geeks website. So for example, this is the array 4, 6, 7, 7. Okay, and now you need to create subsequences of it. So one approach that comes to my mind when we need to create all possible, different possible and things like that, subsequences or sequence subarrays, a very common thing that comes to my mind is backtracking. So let's do it. So we have a solve function, the main solve function, and it will call a solve function for the 0, 1, 2, 3. So 0th index. And at 0th index, the array will look something like this. That we only have 4 in our array because array was initially this array was empty, so we have pushed 4 into it. At the 0th index, I will call s of 1, and the new element is 6. So 6 is greater than 4, and it is given in us in the question that the sequence has to be non-decreasing, which means basically it has to be increasing, or which means the new incoming element should be greater than or equal to the last element in the sequence. So 4 is the last element in the sequence and 6 is the new incoming element, so 6 is greater than that, so we can definitely have it. So this is what sequence will look like. Now after s of 1 we have the option of s of 2. I will take it, and at s of 2 the sequence is 4, 6 and 7. We can have 7. Why? Because we can have 7 because 7 is greater than the last element, that is 4. And at s of 2 the next is s of 3, and this will make it as 4, 6, 7 comma 7. This is also fine because 7 is equal to the last element. And at s of 4 we are getting out of the array bounds, index bound, so we will just stop it, and then I will backtrack to this part, and I cannot go any other yes, then I will backtrack to it, and then I will again, and from s of 3 the array that I have with me is 4, 6, 7, 7, right? And the index is exhausted. While backtracking, the index is exhausted, so I will note this array down. So this is 4, 6, 7 and 7. I have noted this array, and then I will backtrack from 3 to 2, and at 2 I can, for example, I have walked 3, right? But I can also go to 4, s of 4, but s of 4, yeah. And s of 4 will also give me the wrong value. That is it. It doesn't have the, it will return. But at s of 4, before going to the next function, what I will do is I have 4, 6, 7. So basically, I'm not creating copies at every recursive call. I will be using a reference of this array, and when I'm backtracking, I'm popping the value out. So for example, I have pushed 7, and at the time of backtracking I have popped 7, right? That is why I have 4, 6, 7, and I will store it or register it into my set in order to avoid duplicates. And then s of 2 I will backtrack to this part, right, at s of 1. And at s of 1, first of all I'm going to register this, and after registering it, and I have popped out the element. After registering it, I have the option of s of 3, right? At s of 3, this will basically give me 4, 6 and 7, but we already have 4, 6 and 7, so we are not going to have it because this will be a duplicate subsequence. So this call is, well, this call will be made and the values will be pushed, but it will not impact the overall answer because we already had the same subsequence. So we will backtrack to it again. Yeah, and this point, after this I will also make an s of 3 call and then s of 4 call, and at s of 4 it will be terminated obviously. And then we will backtrack to s of 0, and at s of 0 we can now go to s of 1 is traverse, so we can go to s of 2, and at this point we have 4, and now we don't take 6, right, we take 7. And at s of so we have this value, and now we will go to s of 3. At s of 3 this will be like 4, 7, 7, right? And then we are at s of 4. At s of 4 we don't have anything, we will be just terminating because that's out of bound index, and after terminating it, when we are backtracking we will be storing this value, so that is 4, 7, 7. And when we are done with this value, so there is no other option left. We can go to s of 4, but it will be returned. So after this we will backtrack from third function as well and backtrack to 2. At 2 we don't have any value, so we will just simply register it 4, 7. And when this is done, we will backtrack to s of 0. And at s of 0 we have done s of 1, we have done s of 2. Now we can try s of 3, and at s of 3 this will be 4 comma 7, which is the same thing which we have already registered, so we don't need to register it again, and this will be done. And by the way, this will not be done like this, we will also have s of 4 and then it will be done, and now we will have s of 4 and it will be done. So now 0 is done. Now we are backtracking to this part. So at this point we were starting at 0, but now we will be starting at 1, and we will be doing the same procedure for the subsequences that start with this. And at s of 1 you have the sequence as 6, and then you will have s of 2, the sequence will become something like 6, 7. Then you have s of 3, the sequence will become 6, 7, 7. And then you have s of 4, which is going to return. Now you are backtracking, you don't have anything left, so you will register it 6, 7, 7, and then you are done with this function as well. Then you will backtrack to 2. Now you have done s of 3, you can try s of 4. Well, you will be trying s of 4, but it will be returned. And then you will be backtracking. While backtracking we'll be registering the value, so we have 6, 7. And then we can try s of 3, which is again 6, 7, so it will give us the same value. We can also try s of 4 and it will give us the wrong value, and so not the wrong but we will return, and after returning we will be left with s6 only. And when we are backtracking, we are not storing 6 because it is given into the question that we need to store the values that have size. We need to store subsequences that have size greater than 2. That is why we are not storing 6. And that basically means now we can try s of 3. At s of 3 we will have 6, 7, 1, and same thing, we have already have that, so we are not going to try it. And s of 4 will be returning, and then we will be going backtrack again. And now you have s of, so basically that was s of 1, now you have s of 2. At s of 2 you can go to s of, and at s of 2 you have 7. At s of 2 you will go to s of 3 and it will give you 7 comma 7. And then you can go to s of 4, you will backtrack. While backtracking you will see that the sequence size is equal to 2, so you will register it as your answer, one of your answer. And then you will go back again, and s of 3 is completed. Now you can go to s of 4. S of 4 will return, and now you will go to s of 3. S of 3 is completed, so you will backtrack to it, and then you can go back to the, so this was s of 2, and now we can go to s of 3. and at s of 3 this is just 7, and s of 4 will return, and it will have only subsequent that is a length equal to 1, which is not acceptable. So these are the, and then it will backtrack, and now we have s of 4. We will not be going to s of 4 because that's, or we will be going to s of 4, but we will return and insinuating that this function is completed. So when this function is completed, we have these 1 2 3 4 5 6 7 8 subsequences that follow this condition of non-decreasing order. And let's see, do we have them? 1 2 3 4 5 6 7 8. Yes, we do have them. So let's solve this. By the way, now analysis, the time complexity for this part. So for every element you are doing 2 raised to the power n computation, right? Because there's a choice that either you will take this element with depending on the condition or you will not. So for every element you have this 2 raised to the power n choice, and which means n into 2 raised to the power n is the time complexity, and space complexity is also same, that is 2 raised to the power n into n. Why? Because there could be maximum 2 raised to the power n possible subsequences, and every subsequence will have, on average case, have the size of length n. Okay, so now let's get to the coding part. Let's code this backtrack solution. So at first you have an int n that is equal to nums dot size, right? Then you have a set in order to avoid the duplicate subsequence, and the name is s, and then you have a vector that is named as sequence, and then you will call your solve function, which will take the first argument as the nums, then the second argument is the index which it is starting from, that is 0, and then you have a vector, sorry, not vector, the sequence, and then you have s as your set. Now we need to return a vector of int, vector of int, not the set of vector int. So for that I will saying answer, and the set that I will have will be converted into the a vector of int, and then we will return the answer. So let's see, let's make this solve function. So solve vector of int reference nums, then you have an index 0, and vector of int reference sequence, and set of vector of int references. Now there are conditions. So if index is equal to nums dot size, so this is the point where you will realize that you are backtracking, and when you are backtracking you will make sure to check a condition that if the sequence dot size is greater than or equal to 2, then s dot insert this sequence, otherwise return, simply return. Now another condition, if the sequence dot size is equal to 0, that there are no elements, or then you will do these operations, or the another operation is if there are elements and the back element is let's say the condition is the back element has to be less than or equal to nums of index. So if this is the case, then you will be pushing the element into the sequence. So sequence dot pushback the nums of index. After pushing it up, you will call the solve function recursively for the next index in order to check the next index. So this will be nums, then the index plus 1, then you have sequence, then you have s as your set, and while backtracking you will pop these elements out. So sequence dot pop back. But at the last part, because we are using a generic function in order to call itself again, then we will make a solve function. We will call a solve function again when we are done with each number, and the index will be incremented, that now we are done with the 4 computation, and now let's jump to the 6th 0th index number computation. Now let's take the first index computation. So that will be nums index plus 1 and sequence, and then you have s. So I think this should work. Let's see if there are any errors. If there are errors, then then we are going to solve it. Otherwise, we will submit it. Okay, and it is performing quite good. Yeah, the same thing. Hmm. So yeah, this is a solution, and on the space part as well, it's performing good. Although it's a brute force solution, so I don't know why I'm saying that it's performing good, because there are not much approach. There are no many approaches for this problem. But there's another approach that is called bit masking. And a bit masking is a term that is considered as advanced. Although I'm not sure if you can delay the bit mask concept, because in a lot of good product based companies this topic has been asked, so it's better to just have a knowledge of it, right? So the second approach is bit masking. So what is a bit masking? So for example, we can represent a set. So for example, we have this 4677, this number 0123, right? We can represent the subsequence as a number. How we can do this? With the help of bit mask. So let's say we have let's say we have 467, or let's say we have 477, right? This is a subsequence, and what are the indexes? So this is 0, this is 2, this is 3, right? How to represent it into a number? So we can say that 2 raised to the power 0 plus 2 raised to the power 2 plus 2 raised to the power 3, because it's a bit mask. So I will create this bit mask, and this will have a representation like 2 raised to the power 0 means that we have 1 at 0th condition, 2, 3, 4, and 5. And then at 1 there is no element, there is no 2 raised to the power 1, and then we have 2 raised to the power 2, 1 here, and 2 raised to the power 3, 1 here, and then 0. So this is the binary representation of this number, and if you want to find the value, this will be 1 2 raised to the power. So basically we have to calculate this value, plus 4 plus 8, so this will be equal to 13. So this set could be represented as 13, which means if we have the total number of the total number of the possible subsequence is equal to 2 raised to the power n minus 1, right? Because an empty subsequence is not allowed. So 2 raised to the power n can be represented as um yeah, so 2 raised to the power n can be represented as, so there are n bits, right? And we have, yeah, so there can be n, and I think the number, yeah, so it's 15. So because the size is smaller, and we can use a 32 unsigned int and store the as a mask, and in it we can have these position of bits and up to 15 as the maximum value, because that can be the maximum length. We can have all ones, and slowly, and therefore we can so this is the maximum value, right? This is the maximum value when we are including everything. Although this is like not a possible, this is a possible subsequence, but this subsequence needs to be checked. Every subsequence actually needs to be checked if it is following a condition of non-decreasing or not. If it is following a non-decreasing condition and the size of the subsequence is greater than 2, then we will be storing it into the result. Otherwise, we will not be storing it into the result, and we will go and check the next solution, the next subsequence. So for the time complexity of this solution, bit masking one, this is also similar, 2 raised to the power n, because we are iterating over all of the subsequence, that is 2 raised to the power n, multiplied by n, because every subsequence needs to be checked if it is a valid non-decreasing subsequence or not. And according to the space complexity part, it is also same, we are storing the subsequence that has an average length of n. So let's start this implementation. So for first we have int mask that is initialized with the 0, let's say, and then you have yeah, so you don't need mask because that will be initialized when we are using a for loop. And now you have a vector int that is s, that is a set, or let, yeah, the set only. And then we are starting with int mask is equal to 1, and mask is less than, now this value will be 1. So this is a right shift, sorry, the left shift. When we are left shifting, we are basically, you know, increasing the value. And n, actually this will not be something like this, that everything is 1. This will be like this, that at this nth position it is 1, and these are all the number of subsequences present, and we can study them. And mask is incrementing, which means, and this is basically 2 raised to the power n minus 1, because we are not including 2 raised to the power n. And mask is incremented, and every mask will represent a set. Every number of this mask will represent a subsequence. Okay, so now the condition to check is, so first of all we need to have a vector of int that is a sequence. Then we have int I is equal to 0, and I is less than nums dot size and I plus plus. Now if the mask, so if mask of is left shifted by ith bit, right, and it is and with 1, so basically at this point we are checking if the ith bit is set or not. If it is set, if it is a set bit, then it means the ith number has to be taken into the account, and for that I will say sequence dot pushback nums of I. Okay, and we don't need brackets. Yes, now we need to make a check that if the sequence is right or not. So first condition is sequence has to be of the size greater than 2 or equal to 2. And then we need a bool, a flag, or not flag, actually it should be a non decreasing, and that is true. Initially it is set to be true that it's a non decreasing subsequence, but we need to check if it is actually a non decreasing subsequence. So what we will do is int I, now int I is equal to 0, I is less than sequence dot size minus 1 and I plus plus. And at this point I will check if sequence of I, okay, so look, it has to be smaller than or equal to, right? But we need to break out of this with a false condition, and that is if it is greater than the sequence of I plus 1. So if this is the case, then I will say that non decreasing is false, that it's not a non decreasing subsequence, and I can just break out of this loop. So after this we will have this value that either the non decreasing is true or false, and if it is true, then it means s dot insert this sequence. And when I'm done with this, with checking every possible subsequence, then I can get out of this loop and form my answer, that is vector of int answer, and s dot begin, s dot end, and return the answer. Although I have a strong feeling that this will not perform very good, because we are checking every, okay, nums dot size, because we are checking every possible subsequence, right? Because in backtracking solution I think we are not checking every possible subsequence, but in this one we are. On an average case in backtracking we are not checking every possible subsequence. So this, yeah, as I told you, this will not perform very good idealistically. And yeah, because memory wise also, but still I think this is a very impressive approach, and it still gets accepted, right? So I think it's worth it to make a video on it. And yeah, so this was the problem, and the time and space complexity as discussed will be similar. Although I think in Java and Python the hashset function is more like a, by default it can hash like integers or a set of integers, that is vectors or array. But in C++ we are using this function, that is set, and the insertion will take log n time, as well as the duplicate. If we are, even if we are inserting a duplicate, it will also take log n time in the checking part of it. Yeah, I think in C++ this will be much slower because of the implementation of this set, because we are basically using a red black tree. But in Python and Java it will be much faster. because in Python and Java we are basically using a hash set. Hashing is done. So anyways, I think the question is solved, and if you, the algorithm will be same for any other language. So I think, yeah, this is it, and thanks for watching and have a good day.